Okay, thank you, Vicky. Hello, everybody. Good morning, good afternoon, good evening. It's me again with the sixth version, or not sixth session of our Kea DHCP server sessions. And this time it is about migrating from ISC DHCP to Kea. And first I would like to talk about software migrations in general. So from time to time, it's required that we migrate from older to newer software products because software becomes old, becomes obsolete, and designs that have been chosen some 25 years ago might not be good enough for the modern network. So it is not possible to just always upgrade the existing software so that it gains all the new required functionality. And so a clean start is needed from time to time. And such new implementations often cannot provide 100% compatibility with the old product. Examples have been the transition from bind 8 to bind 9, which took multiple years, or still ongoing from Python 2 to Python 3, or now from ISC DHCP to Kea DHCP. And whenever we are facing a migration, I think there is two fundamental ways to approach such a migration. One way to do a migration is to upgrade an existing infrastructure, like letting the infrastructure just as it is, just exchanging the software. But everything else, like configuration, the general configuration of the network, the placement of the DHCP relays and such would stay the same, or take software migration as also an opportunity to redesign the existing infrastructure, because the infrastructure might be almost as old as the software that's running there. And decisions made some 20 years ago might not be the best decisions today. So it's maybe time to take the lessons learned over the last years and try to roll a new infrastructure, have something that is a better fit in the modern landscape. So such a redesign can be used to remove shortcomings, like are there any modern features that can only be used, like modern features in the software that can only be used in a new design, of the network? Maybe now it's time to introduce IPv6 in your network, or to implement new features, something like automatic configuration management, which is now much easier with Kea than it was with ISC DHCP, or monitoring, like monitoring with Stork that we have seen in the last webinar, or, and that is always my favorite, do a better documentation than last time. DHCP configurations can be quite complex. I've seen ISC DHCP configuration files with over 1 million lines in there. And migrating such a complex and large configuration can be very challenging, and there might be unknown pitfalls in there. So testing and monitoring is very important. And later in this webinar, I have some ideas how to implement testing and monitoring for migration from ISC DHCP to Kea DHCP. And also the Kea DHCP team has created tools to help with that, like Stork, which is the monitoring tool, or Perf DHCP, which is a performance testing tool. While an automated migration of an existing configuration might be possible, please be aware that automated migrations don't utilize the power of the new system, meaning the old configuration can only have functionality in there that was available in the old system. The new system might be a superset of that, might have more features, more nice modern things that you want to use. However, these new features naturally cannot be in the old configuration. And if you just copy over the old configuration and migrate that with an automated tool, then you end up with the configuration which more or less does like the old one, but it doesn't do the new stuff. Also, automated migrations might create a configuration that might be non-optimal and harder to maintain compared to a manual migrated configuration. So my recommendation here is, if at all possible, it's much better to take time and start clean. That is, not trying to automate the migration of the configuration, but try to think about the new features, think about what you would like to implement, and then maybe with the help of an automated tool, but not completely relying on that, do a manual migration. That way, you might even be able to identify parts of your old configuration which are obsolete, which are not used anymore. They might have been in use 10 years ago, but maybe they are not there. So it could also be an opportunity to do a cleanup of your configuration. But still, there is a way to do an automatic configuration migration, and that is with the Kea Migration Assistant. The Kea Migration Assistant is a tool that has been created by ISC to help migrating an existing ISC DHCP configuration over to Kea DHCP. And that output can be used as a starting point, or as certain blocks from there could be then reused in the Kea configuration. But please don't expect miracles from the Kea Migration Assistant. In most cases, it will not be able to convert a complete ISC DHCP configuration to a Kea configuration. This is just because ISC DHCP configuration can be very complex, and the features provided by the different products are different. So it helps to run Kea Migration Assistant on the older configuration, but don't expect to do that on a Friday afternoon and be up and running with Kea and then in the evening on that Friday. It takes more than that. So the Kea Migration Assistant is very good in converting fairly simple configuration structures like reservations. So if you have a lot of reservations, and I have seen customers with over 100,000 reservations in their ISC DHCP configuration file, their Kea Migration Assistant really shines, because converting them all manually, like typing them all new in, would be a lot of work. These reservations can be just migrated over. Also, subnet and shared network definitions, like the IP addresses, the network mask, the pools inside the subnet and shared networks, all that could be migrated automatically. And also the option definitions, like custom options that you have in your configurations. These are quite simple and directly and straightforward to convert. What usually don't work so well is failover configuration, because as we will learn in this webinar, the failover provided by ISC DHCP works differently than the high availability in Kea. Also, there are differences in what kind of hardware types are supported between the two products. And for example, how pools are being used in shared networks, and some features like the ISC DHCP spawning clauses just don't exist in Kea DHCP, so they can't be migrated over. If you want to use Kea Migration Assistant, that's part of the ISC DHCP server. This is because it reuses the configuration file parser that is part of ISC DHCP. ISC provides installer packages for Red Hat-based and Debian-based Linux distributions over at Cloudsmith, and you have the URL here. I would recommend, if you want to use the Kea Migration Assistant, and if you compile Kea Migration Assistant yourself, to do that not on a production DHCP machine, but to do that on a dedicated migration machine. that lowers the risk that the installation will do some harm on the existing and still working ISC DHCP server. If you have a dedicated migration machine, what you should do is then copy over the ISC DHCP configuration file to that machine, do the migration, maybe test the migrated file with a Kea instance on the same machine, which should be a lab machine. And if it works how you expect, then you can transfer over the new Kea configuration to a production system. So here are the steps to compile Kea migration assistance directly from source. It's not very difficult. We download the source code, which is part of the ISC DHCP package. We extract the tar file, and then we do the usual step that is being done for open source software that is distributed in source4. We run the configure script that checks your operating system and architecture and adjusts the source code to work well on your machine. And then we do a make. And in this case, we don't do the make in the main directory because that would build the ISC DHCP server. Instead, we go into the Kea MA subdirectory, do a make there, and that will only build the Kea Migration Assistant tool. Once the build process has finished without errors, it is possible to install Kea Migration Assistance with make install, but however, that is not really required. You can just directly use the binary from the build directory or copy that to some convenient location. And here we see the syntax of Kea Migration Assistance, and we will cover some of these switches in the next slides. However, I would like to point out the -4 and -6 switches, because Kea Migration Assistant can work in an IPv4 and IPv6 mode. So if you have a configuration for ISC DHCP for DHCPv4 and for DHCPv6, you have to run them twice through Kea Migration Assistance, once for DHCPv4 with the -4 parameter, once with the -6 for DHCPv6. So here we see an example use of Kea Migration Assistance on an existing ISC DHCPv4 configuration file. The option -N will place host reservation in the appropriate subnet configurations. This is sometimes required because the way how Kea DHCP works with host reservation is different from ISC DHCP. ISC DHCP only knows about global reservations, so every host reservation is always in a global scope. With Kea DHCP, you have more options. With Kea, the reservations can be inside a subnet, or they can be on a global scope. So when you give the -N parameter, Kea Migration Assistance will try to move the reservations from the global scope into the subnet where the IP addresses being used in the reservation just fit in. If you don't do that, Kea Migration Assistance will create global reservations. And the option -R will control what should happen with DNS names that appear in the configuration file. ISC DHCP can look up domain names in the configuration file and replace them with the first IP address that is being returned by the DNS. So in this case, it creates kind of a dynamic configuration, because whenever the DNS information changes, the A records change in DNS, whenever the ISC DHCP is being reloaded, and it only happens on reload, the names are being resolved. What seemed to be a good idea back in the time is actually not so good, because it can create all kinds of problems. So Kea doesn't do that. And with Kea Migration Assistance, we can select whether we want to resolve all the domain names while converting, or if we want to do that manually later on. And with the parameter path, it will just copy over the domain names from ISC DHCP to Kea DHCP.
Torsten?
Yes, please.
Just a comment. We were just discussing this morning. The reason that Kea doesn't resolve the FQDNs, in fact, in ISC DHCP, it only did that once.
Yes.
And one of the differences with ISC DHCP is you did end up having to restart the server much more frequently because you were restarting often when you made a configuration change. And so when you restarted it, it could reevaluate the FQDNs and resolve them to an IP address. But otherwise, after the initially starting ISC DHCP, it wouldn't be reevaluating those. And so actually the end result is not really what people thought they were doing. Because
yes.
those addresses, will frequently, the names will resolve to a different address later. So that's the reason that we're not implementing this in Kea. Our hope and expectation is you won't need to restart Kea nearly as often as ISC DHCP. And so these, this translation from FQDN to IP address would become stale pretty quickly and therefore be kind of useless.
Yes, and doing a live lookup of domain names to IP addresses whenever a DHCP request comes in, that would be horribly slow, and nobody really wants that. Thank you, Vicky. So here's an example result of the Kea Migration Assistant run on an ISC DHCP configuration file. And Kea MA writes a lot of comments into the Kea configuration that it creates. And sometimes the comments contain links to Kea issues that are GitLab issues, actually. Like here in this example, it says that the configuration declares some subnets, but it has no interfaces config. And there's a reference Kea number 245. And this directly relates to the issue number 245 in the GitLab system at isc.org. So if you want to learn more about these messages that appear in the converted configuration, you can go into the GitLab that's available, open for everyone to look at, and you search for the number and you find the issue and can read what is the current status here, why couldn't that be converted, or might be something that can be converted manually. Which brings us to where are the differences between Kea and ISC DHCP. So what we have to look for when we do a migration. So for the shared network, ISC DHCP permits pools on a shared network level. So you have one pool that is across the whole shared network. And in Kea DHCP, it's different. In Kea DHCP, a pool always must belong to a subnet. And if you have a shared network, that shared network has multiple subnets. So we have multiple pools, each pool belonging to each subnet. That needs to be manually translated because no automated system can really know what you really need in your shared network. And in Kea DHCP, if you are selecting a lease from a shared network, that has a slight performance penalty compared to selecting a lease from a plain subnet that is one without, which is not a shared network, because it is extra processing in there, which hasn't been the case with ISC DHCP, because under the hood, ISC DHCP always had shared networks. So even if you didn't configure shared network, every network was actually a shared network with just one network. It was like a a special case of a shared network with just one in there. So you can argue that like the ISC DHCP always did the slower, more complicated thing, and Kea has some optimization here. When you don't use shared network, you can have the full speed. There are differences in client classification. Kea DHCP does not have the concept of permit or deny that we have in ISC DHCP, the keywords permit and deny, which made it fairly easy in ISC DHCP to just allow certain hosts to get IP addresses from a network and deny others. So this can be done in Kea DHCP as well, but the logic is different. It's not better or worse, it's just different. And you need to look through your configuration, see where you have used permit and deny, and create a configuration in Kea DHCP that does the same thing. Kea DHCP currently doesn't support spawning classes, which are dynamic classes for client classification, which are mostly used for dynamic lease limit configurations, meaning that you create a class per client, and then you limit the amount of leases that client can request from the DHCP server, and that prevents some misconfigured client or some malicious client to eat up multiple IP leases from the DHCP server. As I mentioned, and also Vicky explained why that is, ISC DHCP can resolve DNS names to IP addresses, and Kea doesn't do that. And the Kea migration assistance can resolve the names one time to IP addresses when converting the ISC DHCP configuration. Also, the option inheritance scoping is different between ISC DHCP and Kea DHCP. So if you have different scopes in your Kea configuration file and you have the same option set in the different scopes, then you might end up with a different result in the response message being sent to the client compared to ISC DHCP. We have covered this in the third webinar of the series when we talked about client classification and option inheritance. And if you are looking for more information, you can either go there, or there's a good article in the IC knowledge base on client classification that talks about the option inheritance as well. And one part of the product where they differ quite heavily is the high availability. So ISC DHCP supports the IETF DHCP failover protocol draft that never made it to an RFC. Kea DHCP does not support that failover draft. It implements its own DHCP high availability implementation that works both for DHCP v6 and DHCP v4, and it works very similar for these two different protocols. Both the failover in ISC DHCP and the high availability in Kea, they create a highly available DHCP service. They just do it differently, so the implementation and also the configuration is different. ISC has published a document that compares the two failover modes, and I've compiled the main parts from that document here in the next slides. So one thing where they differ is the number of servers that are in a high availability cluster. With ISC DHCP, it's always two machines that have such a configuration, and you can't have more than two machines in one high availability or failover association. While in Kea, you can have two active, but you can have unlimited backup servers that also receive updates of the lease database and can be used as cold standby machines. For failover relationships, for ISC DHCP, there's one failover relationship per subnet. So you could on a per subnet base have multiple, that is more than 2 ISC DHCP servers doing failover. I've never really seen that really being used because it would also be a quite complex configuration. However, it would be possible. In Kea DHCP, there's always one failover relationship per instance. So it's not broken down to the subnet level. You have failover, you have high availability for all the subnets and all the pools that are on the Kea DHCP server. For the load balancing part, in ISC DHCP, you could, in a certain boundary, you could have a flexible split. You could do an 80-20 split, a 60-40 split, a 50-50 split, and so on. That's not possible in Kea DHCP. In Kea DHCP, we always have a 50-50 split, meaning that both parts of the high availability relationship, both pools have the same number of IP addresses in there. ISC DHCP has this function called lazy lease updates, which allows the server to immediately respond to a client without waiting for the lease updates on the failover peer. And that worked, but it's quite complex to implement and also sometimes complex to troubleshoot. And Kea DHCP so far doesn't implement that. So the server waits for the lease update's completion before responding to the client. So when designing your network and when designing Kea high availability, make sure that the network connection and the latency between the networks between 2 Kea high availability pairs is not too slow and the latency is not too big. So yeah, don't put one node in North America and the other one in Asia, for example, or in Australia, where you have a high latency between the 2 nodes. Better than to have 2 nodes in the same like geographical region and 2 other nodes in the other region. Sending lease updates to an external entity, such as an IP address management system or an inventory database system, that wasn't possible with ISC DHCP. People created workaround by writing custom log entries in the log files and then parsing the log files for certain strings and using that to update the databases. But that was clumsy and often quite brittle. In Kea DHCP, that is quite easy to do. You can do that via a backup server, just sending every lease update to the backup server and then read from the database there. Or you could even do a custom hook library that directly speaks the native API language of whatever target system you have. And the rebalancing of pools, that means if a pair of high availability server was broken, so one node was out of service for a certain amount of time, if that happens, the remaining node will give out more leases during the outage of the other node. When the other node comes back, the node has much less leases than the other one. So the chance that the surviving one, the one that always will run out of leases is higher than the other one that was down for a certain amount of time. To mitigate that, ISC DHCP then started to rebalancing the pools, and that could take a certain amount of time and was also complex to implement. Kea DHCP doesn't do that, but in reality, the effect is quite minimal. It could be that if one Kea high availability node runs full, that a client sending the request to that node will not immediately get an answer, but it will then get the answer from the other DHCP server. And the last slide on the differences between the high availability implementations is Kea has database replication for sharing the lease information. ISC naturally does not have that because there is no database backend for ISC DHCP. For Kea DHCP, we can do that, but it's optional. You don't have to do that. And on the API level, ISC DHCP has OMAPI, which is not a really nice API to work with. And Kea DHCP has a RESTful API, which is a really nice API that exposes a lot of functionality from the server. So I already mentioned about the host reservation differences. In ISC DHCP, all the host declarations are global, while Kea supports global, but also per subnet and shared network reservations. With ISC DHCP, you can end up with reservations which don't work in any of the subnets where the client is currently attached. And in Kea, if you have per subnet or per shared network reservations, Kea will detect the misconfiguration and will refuse to start if there is an address or a prefix being used that doesn't fit the subnet. Also, a difference is, of course, the scripts and tools. There are quite a number of third-party tools and scripts being written for ISC DHCP, for example, to work with the lease database file of ISC DHCP, parse the lease file. There are SNMP monitoring agents, and there are configuration orchestration systems like Ansible and SaltStack that can write ISC DHCP configuration files. When you do a migration and you use any of these third-party tools, check out if the same functionality exists for Kea. It might already exist. It might be just in a different place than the ISC DHCP stuff. And also many use cases can be covered by the Kea APIs. Things that had to be done quite manually with ISC DHCP are now quite easy to use with the API. So maybe now it's a good time to ask for a poll about who already started or has experience with migrations. Vicky, would you like to do that?
Yeah, I didn't actually create a poll question for this because the polling feature of Zoom doesn't allow, random answers. But I thought it would be interesting to just ask of the folks who are participating, who have done a migration, if they have any comments about what was unexpectedly difficult or unexpected in any way. Any suggestions that you have to share, with other folks who are attempting to do the same thing. You could comment in the chat, or you can raise your hand and we can just let you speak if anybody's interested in sharing their experience. Whoa. So John says that he migrated just last week.
Very good.
If, pardon me, I pronounced your name wrong. If you
Yes.
are interested in sharing your experience, yeah, okay, so go ahead. Just curious, what kind of a deployment was it you were migrating?
Well, I'm currently working as IT security architect at a Swedish government, and I was trying to do the migration from ISC DHCP to the Kea in my lab environment, and it was quite good. I didn't have many. I used the Kea migration assistant, as you spoke of, and it was quite straightforward. My configuration wasn't that difficult and complex, so it was quite easy. I was the same time trying to do the Stork installation and configuration, and that was quite confusing because I got a lot of errors between the different parts of the control agents and stuff so I'm still trying to figure everything out and get a clean setup. And what I was hoping to find is some kind of easy sort of architectural schedule of the different components into one picture, basically. But I guess I need to do some reading and learning to do this stuff. Quite
yeah,
good.
so, sorry to hear about your experience with Stork. That is under active development and
Yes,
fairly mature, and so it isn't as stable as Kea is itself. We are adding some in the upcoming release of Stork.
I think
adding more error checking to make sure that all of the components and hooks that Stork requires are present, and we'll be giving some more useful messages. I think though that the whole process of doing a migration,
I think my mistake was I tried to use MySQL as a DHCP database and Stork in Postgres. So I needed two different databases on the same machine and stuff. So I sort of mixed it up somewhat, and I will redo it and make sure I do it properly this time.
Oh, so I guess the thing I'm interested in is I think there's a lot of fear about doing a migration because honestly, many folks who are running DHCP in their companies may not have been the person that set it up. And right. As Karsten hinted, frequently the documentation is very limited. At ISC, we have people who come to us and they say, can you maybe tell us how our DHCP is working? And so this is, it tends to be a very dusty area of network infrastructure. And so people are a little bit loath to touch it because they just don't know, what the impact might be. Yes, so I think it's valuable to hear from people who did it, who did not have a disaster.
Well, it's good stuff because I've been using it since the 90s. And so I've been a long time user. I love it, basically.
Anybody else have anything to share, positive or negative? Okay, so maybe nobody else wants to.
Yeah, we can talk about that also at the question and answer section.
Yeah, okay. Well, why don't you keep going then?
Yeah, well, thank you.
Thank you very much for sharing, Johan, your experience so far.
So here's some information about manual migrations and what can be done. So here's an example of the Kea Migration Assistant has translated a client classification rule from ISC DHCP to Kea DHCP. And you see that it has in the comment, it has the original line from the ISC DHCP configuration there. And this is quite straightforward. So if you read the match if substring hardware 1 to 3 bytes equals this hexadecimal string, you find that more or less directly in the Kea expression there. We have the test, and that takes a substring from an IPv4 DHCP package, the MAC address, it's called now MAC, not hardware, 0 to 3. So the counting is a little bit different here, and then we have the same hexadecimal number here. So that was easy. You just go through there and look if it really makes sense what Kea MA has produced. However, sometimes, even though Kea MA does the right thing, you end up with configurations which are not really easy to maintain, and that should be cleaned up. And here we have examples of client classes that has been generated. And because these client classes didn't have a name in ISC DHCP, but they must have a name in Kea DHCP, the Kea Migration Assistant created something, what a program would do. It has a name of gen hashtag VirtualBox hashtag bang known hashtag and bang Microsoft client. And then you see the test. While it is working, it might be not the best way to test this in this order. So in this case, it might be good to review what was the original intent of the client class and see if with the expressions available in Kea DHCP, if it could be just expressed a little bit easier than what Kea MA has created here. So don't get me wrong, this will work. It will do the same stuff as ISC DHCP, but like if you look at these lines in 1 or 2 years, and you might then just think, oh, what was this? What is this really doing? So you end up with a configuration which is hard to read. The ISC DHCP configuration file is almost a complete programming language, and most effects of the ISC DHCP expression can be created with the Kea DHCP functions, the expressions available in Kea, or with the various hook libraries like with FlexID or the flex option hooks. But if that fails, and I had in my own configuration, in my own little network, but I had some like booting for MacBooks and Mac machines. I had some very complex ISC DHCP expressions. In that cases, it required, or it could be done with either custom hooks or look at any of the third-party hooks that other people already have written. And here's a link to GitHub with a search just for Kea and hook. And that gives this list of already 11 results there. And the first one, for example, is quite interesting. It is a hook that calls a script. And that can be a shell script, but it can also be any kind of executable. So it can be Python, could be Ruby, could be anything that is then be run from Kea on every lease. Of course, doing a hook that way is a performance penalty because that script will be called for every DHCP package. But if your system is not under high stress, that might be a solution, because then you don't need to create a hook yourself in C++. You can use your favorite programming language, a scripting language, to do that. And there are other hooks as well. And either they already do what you're looking for, or they can be used as a template, as a starting point to create your own custom functionality in Kea. So how would you go into a migration? Now, these are a collection of how I approach a migration, and I've done like hundreds of migrations over the last 20 years, not from ISC to Kea, but from ISC to Microsoft DHCP, from Microsoft to ISC DHCP, so back and forth between these two products, and also a couple of commercial DHCP products that I've migrated. And what we start up is the old system. In our case, it's the ISC DHCP. And usually we have networks that go through routers with DHCP relay agents. And if we have such a system with relay agent, it is very convenient because we can then switch over one network at a time if needed. So in the beginning, before starting the migration, I recommend to get familiar with Kea DHCP, get familiar with the new features, with the configuration, with the way how Kea DHCP works. I would recommend to at least run Kea DHCP in a small and low-risk production network for at least half a year, or or some months, like 3 months or so, to get an experience on how to operate a Kea DHCP before attempting to migrate a larger, maybe more risky network. And also, even if that small low-risk network doesn't require certain features, but if you would like to run that features in the production network, try to implement them also in this small and low-risk network. So this is this step. And here we have Kea DHCP installed, and we have Stork installed, and we have Stork configured to already talk to the Kea DHCP so that we see some data flowing in. Still, the DHCP relays all point to the ISC DHCP. So we install Kea DHCP alongside the existing ISC DHCP, and then we write and test the Kea DHCP configuration. We either do that manually or with the help of Kea Migration Assistant. And then we configure the DHCP relays to forward all the DHCP messages to both machines, to the production ISC DHCP and the Kea DHCP. Most network equipment can do that. You can have more than one IP address in there, and they will multiplex the addresses. They will send they will forward the DHCP request to more than one machine. But because we are not sure that the Kea DHCP configuration is flawless and is working as we want it to be, at this point of time, we block all the responses coming back from Kea DHCP in a host firewall. Basically, we block all outgoing DHCP messages from Kea. That way, we have a Kea machine that works like in production. It receives all the requests. It needs to do all the lease assignments in the database. It sees the full load, as it would say in the real world production. Still, the clients will not be affected at all because they will not see any DHCP messages coming back from Kea. So this could be done in the operating system's firewall. I, for example, use NF tables firewall in Linux, or IP tables, or in a BSD, a PF firewall, something like that. And then inspect the responses coming from from Kea DHCP that you see in the firewall, and compare them with the responses from ISC DHCP and see if they match or if they are similar enough to work. And at that stage, also implement logging and monitoring for the new system. This is how that would look like. So here in the rightmost DHCP relay, we have configured that one to send the requests both to the ISC DHCP and to the Kea DHCP, but the firewall will block all messages coming from Kea DHCP back to the clients. So the clients will never see Kea, they only see the ISC DHCP. That needs to be thoroughly tested because you don't want to have two DHCP servers which have their own lease management responding back to the clients, because that would create duplicate IP address assignments in your network. That would be bad. So the firewall needs to be really sealed. And then if that is all working fine and good, and you have confidence that Kea DHCP does the same stuff as ISC DHCP or does it better, then define a timeline for the migration and start then with lowering the refresh and the lease times on ISC DHCP before the migration. Because with lower lease and refresh times, you are more flexible. You can do a migration of a network like in a day, in a work day. You don't want to work like if you have lease times of multiple days in your network. You don't want to wait multiple days to experience the first issue. And then if you experience the issue and you decide that you have to roll back that network, you don't want to wait multiple days until the rollback is finished. So a 1 hour DHCP refresh is safe for most devices in my experience so far from the last 20 years that I've done such migrations. Modern operating systems such as Windows, Linux, macOS, and also the various mobile operating systems, Android, which is a Linux, or the Apple devices, which is actually kind of macOS there. They even work with very low DHCP refresh times, even low as 5 minutes. But older DHCP clients, something like MS-DOS or Windows 9X or QNX, and you might ask who runs this old stuff there. I've seen networks where these machines, these operating systems are still being in use because they are part of some industrial control units, and they've never been updated. They will not be updated, which is also not a problem because they are in a controlled environment, not exposed to the internet, but still they are using DHCP. So in these environments, use safe refresh values like 1 hour, and if it is a high-risk network and a high-risk machinery, do some tests before you decide on the refresh values. And then we switch over one network at a time. And we should start, and I propose to start with low-risk networks. Something like wireless networks is a good choice here, like guest networks, the Wi-Fi network of the IT department, something like that. That is what I call a friendly crowd low-risk network. And then we continue switching over networks one by one. And after every switch, we wait a certain amount of time and see if there's any regression, any support tickets being opened because something is failing. And in the beginning, for the first 10 networks, usually you have to wait longer times, but then you know what can fail and you know your networks better and you know how Kea is working on the networks. Then it's then possible to switch bigger blocks like 10 or even hundreds of networks one time. If there is a regression, if something goes wrong, because the ISC DHCP is still there with the original configuration, you can always switch back that one network that had the regression and investigate. But this will not necessarily stop your migration. So while you're switching back one network, you can still go on and switch over the other networks, unless it's a fairly big regression that is very likely to affect all your networks. But if that happens, then you possibly haven't done enough testing beforehand. So, and then at some point of time, we have migrated all the networks over to Kea DHCP, and ISC DHCP is there idling. You should somehow monitor the leases on the old ISC DHCP as well. Really make sure that there are no lease requests, no DHCP requests are coming on there. Not that you have just missed some relay agent somewhere that is still sending DHCP messages to the old machine. And if you don't see any DHCP request for a certain amount of time, like a week or 2 weeks, then it's time to shut down the old system and maybe get rid of that. And then the migration is done. Party. So, and this concludes the migration to Kea webinar. The IC webinars will now take a break of the holiday season, and all the new webinars will be announced early next year. And here I have a number of resources. My colleague Alan Clegg did a similar talk at NANOC 76 about DHCP migration to Kea. If you want to read about the high availability versus the IC DHCP failover and the design document, here are the links. And also IC maintains a list of the third-party hooks for Kea DHCP that are known. And there's a fairly new and very good article on using host reservations for Kea, which has just been published end of October. Any questions?
I've also just put up a poll as people can, as I think about it, just answer. There are 2 questions. The first is about any thoughts you have about what we could do to improve the webinars. And the second is about other topics you'd like to see a webinar on. unfortunately, the poll tool in Zoom doesn't allow you to give open-ended answers. So we welcome other suggestions other than the options I've given you. Just feel free to type any other thoughts into the chat. While we're doing that, we do have one question, it looks like from Ben. What minimum safe lease time values have you observed for older systems in production environments? And I think he maybe is talking about these, older legacy clients.
Yes. 1 hour is a value that is or has been safe for most times. I've seen, I think, once old systems that needed or that really didn't work with the 1 hour, but that was broken also in other means. We had to manually restart that machine. Luckily, that was just a handful of machines in that network after switching over, because it didn't recognize the new refresh time. It still wanted to keep the lease for a day or longer. So we had to just reboot that machine or that machines, but it was just a handful.
You mentioned earlier this migration that you did where there were 100,000 host reservations. And
no, I've not done a migration there. I've seen configurations of that type.
Okay. I'm thinking that is perhaps a replacement for not using client classification. I was just curious about.
These were
need that many host reservations.
These were customers that didn't use pools. That is, they didn't use dynamic DHCP at all. What they did is they created their ISC DHCP configuration directly from a script from a database. And every host had a fixed reserved IP address.
So they almost didn't need to use DHCP at all.
I mean, they did, because it is still more convenient than changing the IP address configuration on every host manually when an IP address changes. So it is kind of a centralized management through DHCP, but it's not dynamic DHCP, it's static DHCP. And some people do that.
Okay, I'm sharing the results of the poll. Obviously, the folks who are in this webinar, are probably self-selected for people who like this format. Looks like people like live demos. The reason I put these will be CLIs, I'm just warning you that just the fact that something is a live demo doesn't necessarily make it exciting to watch, but I know Karsten at least is not afraid to do things live. But something like, watching a DHCP server boot up is only
next time I do a migration, I stream that on Twitch.
Be like watching golf or watching paint dry. So other topics, Karsten has already suggested he'd like to do one on dynamic DNS. That is a topic that we have kind of neglected. So that was a winner. Karsten has a bunch of tricks with using YAML instead of JSON that he's interested in sharing. The reason I put one on here, new features in Kea 1.9, is hopefully nobody's running 1.9 in production. And we do have a bunch of new features coming. And one of the most significant ones is security on the API calls. Currently, we recommend, if you're concerned about securing the administrative access to Kea from remote machines, to run a reverse HTTPS proxy. But that's an extra step. It's pretty cumbersome if you have a bunch of DHCP servers. And so we are adding login security for executing the API commands. And that is kind of overlaps with new features in Kea 1.9, but of course there'll be other features coming in Kea 1.9. And if anybody has any other topics that they'd like to hear about related to Kea or DHCP, feel free to suggest them in the chat. It's just not, this format doesn't support open-ended answers. External tools for managing the host reservations and configuration of the subnets. So this is one suggestion for a possible other webinar. We have premium hooks that do this. So we could have a webinar to talk more about the host commands hook or the subnet commands hook. You know, we haven't really discussed those in webinars. We could do a webinar on, you know, get Carsten to try some of these community contributed hooks. The problem is, of course, we're not maintaining those. And so, you know, we can't really, you know, guarantee that they work or will continue working, but that's a possibility. Okay, well, I think that's it, and there are no more questions. So Carsten, I'd really like to thank you for doing this whole series of webinars. As Suzanne has posted in the chat, they are all archived up on our website and on our YouTube channel. And we also have a mailing list, training info at on our main mailer site. You can sign up. There's very low traffic on that. We just announce when we have a new webinar there. So thank you very much for that.
Yes, thank you very much. I wish everyone a good health and a nice holiday season. See you in 2021.
Okay, bye-bye.
Bye-bye.